Hi, welcome to this lesson on trigonometry double angles. Let's have a look at question 4. We want to prove that that left-hand side is equal to that right-hand side. Okay, so both sides look quite complicated, the left and the right. But I'm going to start with the left because it's also got a tan as well as a fraction. Okay, so let's start off with the left-hand side. So that's going to equal to tan 2x plus 1 over cos 2x. Now, tan of an angle is sine of that angle divided by cos of that angle plus 1 over cos 2x. So now I have the same denominator, so I can just add this numerator, sine 2x plus 1 all over cos 2x. Okay, so remember, this 2x is the angle of sine, not 2x plus 1 is the entire angle. So just make sure whenever you're writing that it's very clear and unambiguous at all times. Okay. So how do we get to make this side look like the right-hand side? Well, looking at that right-hand side, that cos x minus sine x, that looks eerily familiar. Now, what do I mean by that? So this is the subtle difficulty to see. Well, we know from our double angle identities that sine of 2x is 2 sine x cos x. And we know that cos 2x has 3 variations. It's got cos squared x minus sine squared x. It's got 2 cos squared x minus 1, and it's got 1 minus 2 sine squared x. Now, if I look at the right-hand side, I want a cos x minus sine x term. The closest thing for cos 2x right now that looks like it could have that is this first expression here. So that's the clue, that's the hidden subtlety you have to look for when you're trying to piece together different identities to use. So this is going to equal to, so sine 2x, I'm going to write that as so it's 1 plus, and then sine 2x I'm going to write as 2 sine x cos x. All right. Then at the bottom, cos 2x I'm going to write as cos squared x minus sine squared x. Awesome. But we don't want cos squared x sine squared x. We want cos x minus sine x. So I can carry on simplifying that denominator as follows. It's a difference of 2 squares. So it'll be cos x minus sine x times cos x plus sine x. Okay? That's the difference of 2 squares. So I've got this term here now, which is great, but now this guy is the problem. So if I can get a factor of this guy upstairs here, and then I can divide him out, then problem solved. Then hopefully we're just left with cos x plus sine x as the other factor. So now this comes the difficult part, the part where we got to see, well, how do I get this 1 plus sine 2x to look like a factor of 2 things, right, that will divide out with the cos x plus sine x term. Right, so remember, the goal here is that if we can get one of the factors to be this here, then we can divide them out, and then we hope that the other factor is this. So here's the little cheat kind of thing. Well, if we know that that's what we want, cos x plus sine x to divide out, then if those divide out, what we want in the numerator left is another cos x sine x. So how do I know that this is actually equal to that factorized? Right, well, we can check, right? So if I multiply that out, I get cos squared x. If I multiply that out, I get cos x sine x. Then if I multiply this out, I get sine x cos x. And then if I multiply these two out, I get sine squared x. Now notice you have a sine squared x and a cos squared x. Adding those together, you get 1. And then cos x sine x cos x, that's exactly the same term, and there's 2 of them, so there's 2 amounts of sine x cos x. Now that looks familiar. That's exactly the numerator expression. All right, so if you ever get stuck and you're not sure how further to simplify, think to yourself, I'm trying to get this fraction, and I've already got a denominator term that looks like it's there, but the issue is that I've got this term here, and I don't know how to get rid of him. Well, if I can get him as a factor upstairs here, then hopefully I can factorize whatever I have here so that it cancels out nicely. And that's exactly what happens. So that is a nice little technique that you can do, sort of reverse engineer the question and see if it works out. Okay, so that does work out, and you're left with cos x plus sine x all over cos x minus sine x. And that is the right-hand side. So mathematically, we have proven, what did we use here? Our algebraic toolkit and our trigonometric toolkit. The trig toolkit was the double angle formulae. The algebraic toolkit was adding fractions with a common denominator, noticing a difference of two squares, and then being able to see algebraically the reverse engineering technique of trying to factorize this numerator term to try and get the terms to cancel out nicely. All right, I will see you in the next one.